Hi everyone, this is a video from the class of October 28th, 29th, it's 29th. So this is all topics for review of homework 4 and quiz 4. So one of the main things we talked about in class was about the systems of linear equations. So if a system has at least one solution, which is this portion right here, it's said to be consistent. Now, there's a subtopic of consistent, so you can have a consistently independent or independent consistent or consistent dependent. So the difference is consistent independent means the two lines cross at one and only one point. Consistent dependent means you have one line, and then when you graph the other one, it's the same exact line. So when we say something's independent, they're two independent lines. They have nothing to do with each other. Dependent means, hey, they're the same exact thing. But the idea is that they're consistent means that they actually have at least one solution. If the system has no solutions, then we call it an inconsistent system of equations. Okay, so we're going to look at a picture now of that. So right here, this is independent consistent, one solution, exactly one. This one's called consistent but also dependent because it looks like there's only one line, but there's two equations that are graphed and they're right on top of each other. And then this is a inconsistent, meaning there are no intersection points, and what happens in this case, we know the two lines are parallel. So how do we solve systems of linear equations? Well, there are three basic methods. One of them is substitution, the other one is called addition elimination, and the other one is graphing. So substitution is good to use if you have an x equals or a y equals in your system. So remember, systems are written with those fancy brackets. You have a function written here and a function written here. If one of them is y equals or x equals, you can use that to substitute into the other. Addition elimination is nice if they line up. So let's say you have something like this. See how they line up? The only thing is you have to make sure that the coefficients in front of any of the two variables, whichever one you choose to look at, if it's both y's or both x's, they have to be the same and the signs have to be different. So that way when you add them up straight down, you eliminate. What that means is you might have to do manipulation sometimes in order to get this to make sense. And we do have examples of that. Graphing, right away, if they give you a picture and the lines intersect, you look at where they intersect. If they're smack right dab on top of each other, remember that's consistent and dependent. And if they are parallel lines and they will meet, those are inconsistent. So let's look at the following 7 questions and make sure that we're confident sometimes, answering them. So for question 1, there are going to be 3 systems. Right here on this paper, you only see one of the systems. 2 of the systems, the other one's on the next page. But you have these 3 systems, and we're basically doing all graphing. So this is a graphical solution. The pictures are given to you. So if we look at the first one, system A, right here, we have 2 specific lines, and we notice it intersects at one point. So let's read what the solution is. The x value is 2. The y value is -1. The system of equations is consistent independent, and this means the system has a unique solution. Okay, let's look at this one. There are 2 lines, but only one line that you visibly see. So we call this consistent dependent. This means there are infinitely many solutions because the graphs intersect all over the place infinitely many times. And there is no solution that you can say because there's infinitely many. The only way you're going to fill in the solution part is if there's a unique solution. System C. System C, look, they're parallel. So here's the 2 lines. They're parallel lines. That means they will not intersect. So that's inconsistent. That means there's no solutions, and so you can't fill that out. Okay? So this is solving by graphing. You look at the picture and you graph it. Let's look at question 2. Here's your system of linear equations. This line here is just a pure and utter accident in the way the PDF was uploaded. So it says, note that you can answer no solution or infinitely many solutions. We're going to graph them. So let's graph the first one first. The y-intercept is -b, and the slope is 1/3. So I'm going to start at -3, and I'm going to go up 1 over 3. 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. And I'm going to go down 1, left 3. 1, 2, 3, down 1, 1, 2, 3, and that's my line. So I do my best to draw, that's not good. I do my best to draw a straight line through these points, and now I've sketched my first one. Now my second one, I have to rewrite that, so that's going to be y is equal to positive 2x plus 2. Y-intercept is 2. The slope is also 2, so 2 over 1. I'll graph this one in blue. Up 2 over 1. Up 2 over 1. I notice that I'm going to have to go down so it intersects, so down 2, left 1. Down 2, left 1. Down 2, left 1. Bing, bing, bing. There you go. They intersect right there. So we draw that line. And that intersection point is at x is -3, y is -4, and that is your solution. So question 3 gives you 2 lines, and it's a word problem. So you have a plan A and plan B. For each plan, the cost is in dollars, so here's your dollars at your y-axis, and it depends on the minutes used per month, and that's your x-axis. If Dale makes 50 minutes, that's x values of long-distance calls for the month, which plans cost more? So 50 minutes is right here. So I look up, for plan A, it'll be $6, and for plan B, it'll be $12. So for plan A, it will cost $6, and for plan B, it will cost $12. Now be careful. How much more does it cost? So B is $6 more than A. Okay, so be careful with that. For what number of long distance minutes do the two plans cost the same? That's their intersection point right here. So that's at 200, 24. So it's at 200 minutes. So they want to know minutes. So it's 200 minutes. It will cost them $24. If the time spent on long distance calls is more than this amount, so if it exceeds more than 200 minutes, which plan costs less? That would be plan B. Okay, so it's just reading the graph and understanding what's happening in that function. Okay, let's do substitution now. So you take, since this is a y equals, you're going to take this 3x minus 8 and you're going to place it in there. So it's 2x plus 5 times 3x minus 8 equals 11. So it's 2x plus 15x minus 40 equals 11. Combine your x terms. That's 17x minus 40 equals 11. Add 41 to both sides. So we get 17x is equal to 51. And divide by 17, and you get x to be 3. Now notice that the question gives you both an x and a y value, so we have to find the y value now too. So inside here or here, doesn't matter, you're going to put an x and you're going to just solve for one of them. So let's do this one. Y is equal to 3 times 3 minus 8. 9 minus 8, 1. And that's 1. So in this video, we will use substitution to solve the system. So notice that in this question, you have x equals. So inside your x, you're going to put the 3y minus 9, but you're going to put parentheses over it. So it's going to be 3y minus 9, plus 5y equals 29. Just make sure that you have all the same variables, so you have all y's. Distribute the 3, so you have 9y minus 27 plus 5y equals 29. Then 9y plus the 5y is 14y. They're still on the same side of the equal sign, so it's minus 27 equals 29. Now we add 27 to both sides. We get 14y is equal to 56 divided by 14, and y is equal to 4. But now we still have to find x, so just substitute it into there. So x is equal to 3 times 4 minus 9, 12 minus 9, and the answer is 3. Okay, let's look at this question. This is solving the system of equations. Notice how your variables are lined up and the equal sign is lined up. So we're going to use the addition-elimination method, and also notice that it's already set up for you. You have the same
coefficient, just different signs, and that will give you your elimination that you need. Sometimes, which you'll see in the next question, you have to do a little extra work, but in this question you don't. So 2x minus 2x is 0, 4y plus 3y is 7y, and negative 8 plus 22 is going to be 14. Divide by 7, y is equal to 2. Now be careful. When you have to solve the systems of equations, you need both an x and a y value. So your y value is 2. You have to find your x value. So pick one of the equations. So let's do the first one. Where there's the y, I'm going to put 2. So we have 2x plus 8 equals negative 8, minus 8 to both sides. We have 2x equals negative 16. Divide by 2, x is negative 8. And that's your solution. So this is the type of systems of equation questions where you have to do some manipulation. So let's say I want to get rid of my x's. I need them to have the same number and they need to be different signs. So what I'm going to do is I'm going to multiply the top equation by 7. I'm going to multiply the bottom equation not just by 5, but negative 5, so that way it changes the sign. And you'll see when you multiply through, check to see what numbers you get. So negative 35x plus 14y equals 112. Distribute here. Positive 35x minus 25y equals negative 35. Now we add up. When you add up the first two terms, you get 0 or crosses out. When you add up these two terms, you're going to get negative 11y. And when you add up these terms, you're going to get 77. Divide by 11, so y is equal to negative 7. Now remember, you need to find your x's as well. So if we take the first equation, and in the y, we put negative 7. So you're going to get negative 5x minus 14 equals 16. Add 14 to both sides. Negative 5x equals 30. Divide by negative 5. X is negative 6. So that's your answer. If you put it as an ordered pair, it'd be written just like that.